Welcome to Challenging GCSE Maths Questions with Mr. Wesley. Every day, we take on one mind-boggling GCSE maths question designed to stretch your brain and push your skills to the next level. Mr. Wesley will break it down step by step so you can confidently ace those tricky final questions on your exam. Grab your notebook, your pen, and your calculator. Let's get solving. Oh, and before we dive in, make sure you hit that like button and subscribe. If you have any challenging questions you would like Mr. Wesley to solve in the upcoming videos, please email him the question. His email address is in the description. All right, let's do this. Here's Mr. Wesley.
Okay, this question is on velocity time graph. Two motorcyclists, David and Peter, begin their journey from the same point A and finish at the same point B. Both start together and finish together. However, their speed profiles are different. David starts from rest, accelerates to a maximum velocity of b meters per second, and then immediately begins decelerating until he comes to a stop at B. Peter also starts from rest at the same time, accelerates until he reaches the velocity of 16 meters per second, maintains this constant speed for a period of time, then decelerates to 0 meter per second as he arrives at point B where he comes to a stop. It is observed that Peter spends half of his total time traveling at a constant speed of 16 meters per second. So out of the total time, he spends half of the time traveling at that constant speed of 16 meters per second. The question is, by sketching velocity time graph for both riders, determine the maximum velocity v that David reached during his journey. So we are going to sketch a velocity times graph, and this is what it looks like. So the blue curve is that of David's journey, and this light orange is Peter's. Now the total journey time, I'm going to take this as 2t. You will see why in a minute, because it says that it is observed that Peter spends half of his total journey time traveling at constant speed. So this is when he travels at constant speed. Therefore, if the total journey time is 2t, this is t. Okay, now we have put all the information given in the velocity time graphs for both riders. Now, the key thing to keep in mind is that when you have a velocity times curve, the displacement is given by the area below the curve. Okay, so if we look at David's journey, that area below the curve is given by this blue triangle, the area of this blue triangle. And on the other hand, if we look at Peter's journey, the distance traveled is given by the area of this trapezium. I'm going to draw this in green so that it will stand out. So this area. So because they both started their journey at A and stopped at B, the distance traveled by David and Peter are the same. So, in other words, the area of the blue triangle is equal to the area of the trapezium. So, area of the triangle is half base, which is 2t, times v unknown, which is what we are after, by the way, and that is equal to the area of the trapezium. How do we find an area of a trapezium? We add the lengths of the parallel sides. So if the parallel sides are A and B, and if the height is h, is half h A plus B. So half h, which is 16, because that's the height of the trapezium, times A plus B. So we could add this to this. This is 2t and this is t. So that's 3t. Okay. So conveniently, half and half will cancel out. T and t will cancel out. What we are left with is 2v is equal to 16 times 3, that's 48. Therefore, v is equal to 24 meters per second. So this is 24. Okay, I'll see you soon.
Great job today, everyone. Remember, the key is to take your time and practice the questions regularly. If you found this video helpful, please like, comment, and subscribe. It really motivates Mr. Wesley to create more videos. If you have any questions, feel free to email Mr. Wesley at WesleyMathsTutor@gmail.com. See you in the next one.